So water is poured in 2021 paper, Tech Active, question 15. Water is poured into a cone-shaped cup at a rate of 2 centimetres cubed per second. The cup has a height of 12 centimetres and a radius of 6, as shown. As the cup fills, the ratio of the height of the water to the surface radius remains constant. Given that height equals 2r, determine a function for the volume of the water in the cup in terms of h and express your answer in simplified form. So these are our, we like these, related rates. So let's look at information given. We'll go up here that the cup water is poured in. That's dV dt is 2 centimetres cubed per second. We know that h equals 2r, or we may want h on 2 is r, depending on which one we're going to want to sub in. We want to determine the volume of V in terms of h. So we want the volume in terms of height. Volume of a cone is 1/3 pi r squared h. We want it in terms of h, so I want to eliminate the r. So that's 1/3 pi. This is where I'm going to use this. R is h on 2 squared by h. That's 1/3 pi h squared on 4 times h, which is going to give me pi h cubed on 12. That was just one mark for that. Where are we going to go from there? Part B. Now we've got part B is going to use what we found out in A to show that the rate at which the height of the water in the cup is increasing with respect to time is given by 8 pi on h squared. So what do we want to find? We want to find the rate at which the height with respect to time. So we want to find dH dt. So I want to find dH dV times dV dt. Now from above, we knew that dV dt was 2, which is good. And we need to find dH dV. All right. We know V equals pi h cubed on 12. So dV dH it's going to bring the 3 in front, 3 pi h squared on 12. So dV dH is pi h squared on 4. So over here, dH dV is going to be 4, flip it over pi h squared times 2, which gives me 8 on pi h squared, which is what we wanted. For that, we want a mark for having our statement, a mark for finding dV dH, and a mark for our answer, obviously. Then we have part C. Now part C says, determine the rate at which the height of the water in the cup is increasing with respect to time when the water volume in the cup reaches half its total capacity of the cup. So we want to find, how fast is the height thing? So we want to find dH dt when the volume is a half of the total volume. Essentially, that's what we're going. when it's half the total capacity. Okay, total volume is going to be, it is 12 high and 6 across. So it is 12 high and R is 6. So let's just go back to our thing. A third pi R squared H is a third pi 6 squared 12. You could also have gone back to using what you found in part A. So what's that going to be? 1/3 times pi times 6 squared times 12. 144 pi. So then at half volume is 144 pi on 2 is 72 pi. Oops. Now, when is our half volume? We want to find dH dt. Now remember, dH dt is in terms of H. So I want to find H when the volume is 72 pi. Going back to A, so from part A, V equals pi H cubed on 12. So 72 pi equals pi H cubed on 12. Now for those of you who could see it, you might just go, okay, I can simplify that really easy and work out what H is, or you could go solve N. Depending on which way you want to go, how far in an exam, if you're feeling a little bit stressed, you might just go, oh look, I'm just going to go calculate solve N. 72 pi equals pi x cubed divided by 12, close brackets. And it gives me H equals 9.52 centimetres. So that's the height when the volume is at a half capacity. And I've got to find dH dt. So dH dt from part B is 8 over pi 9.52 squared. So I'm just using that from B. So gone my trusty calculator. Again, I'm going to go 8 over shift pi 9.52 squared. Oh, exit. Didn't like that. Put the times in there. There we go. 0.0281 would be my answer. Got to go to 2 decimal places, so the rate is 0.03 centimetres per second, rounding off to 2 decimal places as I go. Now with this one, you know, working with your half volume, calculating your height, calculating this, and then giving your answer is a mark. So there's your 4 marks for that part of question 15.